In this video, we are going to look at a couple of equations and determine whether they are a function. So our equations have two variables, an x and a y. X is usually called the independent variable and y the dependent variable. The dependent variable depends on the independent variable. Now, the way we determine whether an equation is a function is whether each value of the independent variable gives rise to a single value of the dependent variable. And if it gives rise to a single value, then it is a function. If it gives rise to more than one value, then it is not a function. So the easiest thing to do is if we have an equation, 4y plus 3x equals 2, for example, which is just a line, we solve for the dependent variable, the y, given x. And so we'll go over here and we'll write down our equation, 4y plus 3x equals 2. We're going to solve for y, so 4y equals negative 3x plus 2. Y equals negative 3/4 x plus 1/2. Now we can see if we plug a single value for x in, we get a unique single value for y. So this is a function. Let's look at another example. X squared plus y squared equals 4. So this is just a circle. Now, if we look at this equation and we solve for y, we have x squared plus y squared equals 4. Y squared equals 4 minus x squared. Y equals plus or minus the square root of 4 minus x squared. And we can see here, if we plug in almost any number for x, we get two values for y. So for example, if we plug in x equals 0, we get plus or minus 2. Now there are a couple of places. If we plug x equals 2 in here, we get y equals 0 always, or x equals negative 2, y equals 0 always. So this is not a function. Because there are many places where a single x value gives rise to two y values. Now, another way we can look at functions, if we go back to our graph for a moment, if we can draw a vertical line and only intersect that equation once, then it's a function. If we intersect that equation more than once, then it's not a function.